Hi everyone. This lesson is about the Trapezium Rule for finding areas underneath functions. So I've set this up here where I have the function f of x equals 0.1x squared plus 1, and I've done a graph of this here. It's this lovely blue curve, and I'm interested in finding the area from a lower limit of 2 to an upper limit of 6. Now, rather than doing a definite integral, I've decided to use the Trapezium Rule. So I'm thinking that I could use 4 sections, and the width of each section would be b take a divided by n. That comes out to 6 take 2, which is 4 divided by 4 comes to 1. And if I use a little straight line across the top here instead of a left or a right rectangle, I get a better approximation for the area underneath the curve. It's still not perfect because I'm using a straight line between the two edges instead of a curve. So it's somewhat different, but not by much. So here's my integration, my integral of this. That gives me the area. And here's my formula for the trapezium rule. W over 2 f of x naught plus 2 times all the in-between ones, which is that's x1, that's x2, that's x3, and then finally the last one, f of x4. Now, how do I do all the calculations? I use my graphing calculator. Here it is. So I'm going to enter into list number 1 the values, the x values. So we started at 2, 3, 4, 5, and we finished at 6. For the second list, I'm going to enter the formula 0.1 times x squared plus 1. So remember, the cursor has to be on the heading there. 0.1 multiplied by, now I'll use brackets, okay, list 1, which is where the x values are, squared plus 1. And that calculates all the values for me. Those are the values that would go into the formula. I can do a bit more. The first x value is multiplied by 1. The that's a boo-boo. The intermediate x values are multiplied by 2, and that last one, where x equals 6, is multiplied by 1. So the 1 at the ends and 2's in between represent the fact that f of x naught is multiplied by 1, all the in-between ones are multiplied by 2, and the last one, oh, I didn't mean that to happen, and the last one, f of x4, is multiplied by 1. So I go across to list 4, the top of list 4 there, and I'll go list 1 multiplied by list 2. Did I say 1 and 2? I meant 2 times 3. List 2 times list 3. And that multiplies them all for me. Now, when it comes to writing some things down on my book to show the working, I will go back to my list, and I see here that, oh, calculator, come back. I see here that when x naught, when x was 2, the function value was 1.4. So that's what goes here. 1.4 plus 2. Now, I need f of x 1. So x1 was 3, the function value is 1.9, then 2.6, then 3.5. Those are the in-between ones, 1.9, 2.6, 3.5. 1.9 plus, and 3.5 was the last one of those. And finally, I need the function value for x4. That's when x was 6. So we'll just scroll down a bit. When x was 6, we have 4.6. Now, adding up all of those things, well, all of those things were multiplied by the appropriate factors and then stored in list 4. I really need to just add up all the values in list 4 to find out the sum inside those square brackets. To do that, I'll go back to the main screen. using the Option key and the List menu with F1. Now I move to the right twice and I have the choice to do the sum. I'll ask for the sum of the things stored in list 4, and it comes to 22. So all of that stuff is 22, and then 1/2 times 22, of course, is the area estimate of 11 square units. Now, just to show on the calculator what's going on here, I could have, exit. I could have on the calculator asked for the integration of 0.1 by x squared plus 1 between the limits of 2 and 6, and I get 10.93. We got 11. That's because we were using an approximate method, but it's very close. We could have got a closer approximation if we had used more than 4 strips. If we had used 10 strips, we would have done better. If we had used 100 strips, we would have done even better. So even though this is an approximate method, it's still a very good technique to know. Yes, in this case, we could have integrated that using a definite integral. It's simple enough to do. Some formulas won't be easy enough. Some formulas, the only way we will have is one of these numerical methods. Okay, the main purpose of this was to demonstrate the use of trapezium rule, and particularly how I use the graphing calculator to save myself some tedious work with all of this calculation, particularly if we had a more complex formula or greater number of trapezoidal segments. Thanks for watching.